It's too cold.
Whenever you guys are ready.
Sure. Do you want to start it off?
Sure. Is it recording?
Yeah.
3D printing by me and Logan. We use tinkercad level 1 drawing 3D objects with tinkercad. Launcher tinkercad drawing 3D objects and with tinkercad.
Oh. Holy crap.
You got this?
Cool. We will use tinkercad level 1 drawing 3D objects to create a 3D object that resembles something by using the tinkercad software and using the 3D printer. In these 4 days, we will create and print out an object as we work together. We will complete this because we have 2 minds and many creative designs that are coming to our mind. We can print our ideas and make them into real-life objects with a 3D printer. On the first day, we'll combine our ideas and thoughts and figure out which object we would like to continue with. The second day, we will start designing our project on a tinkercad website. The third day, we will be done with our design and hopefully be able to start printing.
About our technology. Tinkercad is drawing software. Tinkercad allows you to draw 3D objects or 3-dimensional. With Tinkercad, you may locate your drawings from side, top, or bottom. You can shrink and enlarge your drawing too. You also can copy and paste your objects. Some pictures showing your work with pictures and labels. On the next slide, there are not specific numbers of slides, but this as many as you need to show us how many about them. Oh, oops. Wait, you got this one.
We learned that 3D objects can be hard, but it's good to use your imagination to try building things, even though you may struggle with it at first.
What problems we had? We had a lot of problems with the bowling alley. The walls weren't printing correctly up, and my bowling pins did not come out correctly. Well, either they were different shapes, barely resemble actually bowling pins. I actually did figure out why this was going on. I can show you with one of the basically, he was trying to make these very rounded tip, which caused the thing to fall over during printing, which caused it to turn most of it into spaghetti. So that's what happened. This is his 3D object. I imported it from save files, so then this is what it would look like in real life. Wait, replica. You can use what you can use for a launch for. You can make replicas on a bigger or smaller scale as you did it. So, for example, some people make cells. They need to make that on a bigger scale than ours. Next. Oops, I forgot to change that. That's supposed to be grave. When I realized I already used the image.
What the?
This is the picture of Logan's bowling alley.
Yeah.
The pins didn't turn out perfect, but it kind of works. The ball rolls. But yeah, this is the grave I made. Can they see that? Next.
We need out.
I already cut that.
Oh, yeah.
Look at it.
What do you do? I'm doing this with bro.
This is a picture of the grave you just seen.
Not working the tap still? There we go.
Creating a 3D object with our ideas is what we did. Yes, we both complete our smart goals. Yes, we would do this again. It was a lot of fun. We can bring our ideas to a physical object, like, for example, his bowling alley. When I make a bowling alley, I hit a grave. We're able to get our projects connected. Different filaments have different strengths, is what we learned. Creating art ideas helped each other out when we needed it. We would create out objects with using tinkercad program and 3D print them. That should be the last. Yep, that was the last one.
Oh.
Oh,
That was right on the dot.
don't do that. That was that's stunning.
Okay. Alright, Parker. 1 to 3. We're sticking with 2. Xavier?
Most
3. I'll go
likely
3.
3. It's my going 1, I guess.
You guys are one.
Yeah.
Good luck, Jackson.
Okay.
If you have one misspelled word, I'm gonna Batman laugh at you.
Okay.
Yeah.
And it's just 4 a.m. So. Vinyl printer. That's more temple. Alex and Edwards. Our technology is the roll-in printer and the Votech vinyl unit. That's a thing. Our SMART goal is to use the roll-in printer in order to print out it's supposed to be the number 2 stickers, then shirts. We will use the shirt iron to screen print our chosen design. We should be able to create at least one sticker or shirt. We have all of the materials we need in order to complete this goal. We are doing this because we wanted to try something new and thought this would be interesting. We will reach our goal by day 1, making a shirt, just printing things out. We'll make stickers first was the original plan, but we didn't. This is an easily obtainable goal. Go ahead, bud.
About our technology. Our technology is the roll-in vinyl printer and a t-shirt press. This technology is used in many ways all of the time. Lots of businesses are built completely using just 2 machines. The printer costs about 5,000 smacks, and the iron costs around 200 smacks. Also known as smackaroos.
So many people have been able to build entire companies using only the technology that we've used. They're really popular in like touristy locations. To the left, to the right is sticker prices on average, and below is t-shirt prices. I mean, you probably can't read it, it's really little, but they're there.
What did we learn? In this project, we learned how to print things using the Roland BN20 to create our designs using the software. Learning how to use the adhesive was very difficult. It took a lot of time to figure out. If you wanted to turn a profit using just these devices, you would need to cover around $5,200 or around 150-inch stickers, which there used to be a picture of a 150-inch sticker on our one, but like that's a pretty big sticker. So you're gonna have to make a lot of stuff. We had a lot of issues with the software when trying to lay out our designs. It's really old and wasn't really doing all that great. Kept crashing, and then we'd have to restart the computer altogether. Once we were able to get past that, it went pretty smooth. The only other issue was trying to figure out which material was for t-shirts and which was for stickers. That ended up kind of being the reason that we didn't make stickers, just because, yeah, that was difficult. So the one we are using is this t-shirt printing filament. There's on the Roland BN20 there is a knife that it can't bust through the second layer. So when you do that, you take off the filament around the sticker, you put tape on and you take the sticker off so it can adhere to the shirt. And here's the sticker. You take out this filament and you put this one in, and you basically, and then you print it on here, and then it becomes a sticker.
And the backing on the t-shirt material is really hard to peel off.
Yep.
So please use. Anyway, so these can be like, as I mentioned before, businesses. Well, that's one of our shirts. That's the vinyl printing business. Put words on here.
adhesive, face stock, anchorage, electrostatic printer, dot frame, DPI, bitmap, and band. So we'll go through all of them. Adhesive is the glue that bonds the design or logo to the fabric. Face stock is the material that the design is printed. Adhesive is applied to the back of this. Anchorage describes the quantity of the band and adhesive to the face stock. Electrostatic printer, the printer used to make the design on the face stock. Dot grain is spreading of ink into the material that you are printing. The DPI, dots per inch, the resolution of the image you are printing. Bitmap is the display of your chosen design before printing. Banding, the lines that show on your design as a defect when you are low on ink. So in order to make a t-shirt, there are quite a few steps. So first of all, you gotta find a picture. Your image must be a JPEG, or not, can't be a JPEG or a PDF. So it says that you can use a JPEG, but I've tried it and the software wouldn't allow it. It kept saying that it was corrupted. Yeah, it just doesn't do it. So you gotta either do it right on the computer, or you can put it on a flash drive like we had to, plug it into the computer, print it out. Finding the correct material to print on, which was definitely a challenge because none of it was labeled, and the book doesn't very easily describe. Yeah. So then you obviously print it and then pressing it onto your shirt. And oh, mine's gone.
Oh no.
My shirt was on there, I swear.
What did it say?
It said my shirt,
Cool.
and it said
Maybe it's
it's
on
the
the-
McRib one.
Oh no. What did it say?
Go ahead, buddy. So I looked up some stuff from like words of wisdom. Like I had previously a book of wisdom that I printed out that took 20 full minutes to make, and I didn't put it onto the shirt correctly, and it adhered to the bottom layer of the filament. Very hard to take off. So my shirt is from a wisdom site. Live as if you were to die tomorrow. Learn as if you were to live forever. Mahatma Gandhi. And this is a, I don't know how to describe this. This, my other t-shirt that took a long time to make for some reason. I couldn't get it right. My shirt was a picture of a McDonald's sign that said the McRib is back. Actually, it didn't say the McRib, it just said McRib is back. That's gone. That's a bummer. So the printer came with a couple of these handbook dealios that we were able to kind of learn how to do this from, except they didn't very clearly describe things. So we searched the internet for information and watched a few YouTube videos. Conclusion. Our challenge was to create a couple stickers and shirts. We didn't make any stickers because we spent all of our time making shirts. We would definitely do this again. Next time it would be cool to make stickers. We both enjoyed the process of designing and making our shirts. We successfully made 3 shirts. We learned how to use the ancient software that came with the printer. Emphasis on ancient. My partner and I worked together to figure out the process of making shirts. Yeah. Yes.
Oh,
That was the close one.
I did. I did. Tired. It was loud and clear, buddy.
I'm surprised you didn't hear it.
I actually finished that.
You want?
Never mind. We're good. We're sticking with 2 though.
You're calling 2?
We're calling 2.
All right.
It becomes 2.
Oh.
Okay. Let's go.
No, it just didn't work.
No, I think I just think it.
Okay, buddy.
No, it just did 1 3 times in a row.
Let's
That's-
go.
3.
That's
See, I just know what number I'm
It
picking.
did 1 like 4 times in a row.
You gotta stick with the same number the whole time. Except for
I
like,
did immediately. So how that turned out.
I forgot you did this.
Alright, let's have it take this name to the mind.
Yeah, my name isn't.
Me and Jackson won still, so
My name isn't correct.
we
Did you
won.
spell it wrong?
No.
Good, because I put it in my dictionary.
This is building bridges. My name is Zabin. The technology is Bridge Designer 2016, and the launcher is Level 3 Bridge Designer, designing from scratch with Bridge Designer. SMART goal. Our challenge, my challenge, is to design 2 attractive, creative, and affordable solutions and make it under a budget of $300,000. I will use Bridge Designer 2016 to create a bridge that meets a set of requirements that include money, a length of 44 meters, and using prior knowledge about bridges. I will be able to reach this goal in 4 days by trying different bridges day 1 and day 2, and then finishing the bridge on day 4. I will be able to complete my goal because I have the resources and knowledge to successfully master this goal. I'm creating this because bridges serve a real purpose in the world, and I thought it would be something cool to do. I will reach this goal by figuring out different types of bridges on day 1 and 2, and getting the final product on day 3 or 4. Okay. My technology is an application that is called Bridge Designer 2016 that simulates building bridges in the real world. It's a picture of a bridge, but you can't really tell because it's like grainy. Some vocab words I learned. Arch bridge. It carries loads primarily by compression, which is like this. Whoa, this part, like the blue parts, which exerts on the foundation, both vertical and horizontal. This was the bridge I had the most success with, and I was able to get 2 bridges under the budget. Truss bridge. A single span truss bridge is like a simply supported beam because it carries vertical loads by bending. This was the bridge I had the most problems with because, yes, they were strong, but you couldn't get them any cheaper than they were. Beam bridges. It's like the simplest structural form for bridge spans, supported by abutment or pier at each end. I only tried one of these bridges and it didn't really work that well for staying under budget. What did I learn? I learned that bridges have a big impact on life, more than you would think anyway. Bridges are built with triangles since they cannot move, whereas a square can move at the corners and turn into a diamond, and that is not good for a structure. What problems did I have? I had a problem with finding the right bridges to build. So like what type, this means, arch, truss, suspension, etc. I didn't really get a chance to fix this problem because there were very few bridges that would even come close to being under the budget. This is a bridge, and then this is a arch bridge that was $6,000 under the budget. Day 1. On day 1, I was able to use this type of arch bridge. There was different templates you could use. For example, you could have an arch like mine, which doesn't have a very big like distance from here to here. So this is like skinny here, and then this is like back here. There's other templates where like this part would be like down here, and this would still be up here. This bridge was the one I was able to get down under the budget with. Day 2, this was also a good day since I found a good design that was worthy of being cheaper. There was not a template for this, however, and there was a more accomplished feeling at the end since I didn't use a template and just fill in blank spots. Day 3, this was a down day. I tried making a truss bridge and it did work, but it was $150,000 over the budget. I was trying to make it cheaper though. On this day, it did not. It did work to make it cheaper, but it wasn't cheap enough.
On this day, I was messing with different types of bridges, like ones that had piers and suspension bridges, and like 3 other types. The cantilever one was close to being under budget, so this one was close to being under budget, but not close enough, I guess. My challenge is to design 2 attractive, creative, and affordable solutions and write a professional bid proposal in support of your ideas. I believe I achieved my SMART goal, since my goal was only to get 1 bridge under budget, and that's what we got, and I got 2. I would do this launcher again because I would want to find 4 types of bridges to get under budget. I like that it gave me options. I like that the launcher gave me options on what bridge I could make. I was able to get 2 bridges under budget $300,000. I learned that there's a lot of different types of bridges, more than you would think. And I had a very good process for the 4 days. I would find a popular bridge and just make it cheaper, or as cheap as I could. Thank you, Devin.
Parker. 1 or 1?
I'll go with 1.
Dang. Okay.
Should have went with 2.
You got this video, this,
zero?
this.
Should have went with 1.
Should have went with 2, idiot.
Okay.
Or the other one.
Yeah.
Is your slide this one?
3D printing by Wyatt and Parker. Dremel 3D 20 printer and tinkercad. We use the level 1 tinkercad, drawing 3D objects with tinkercad.
Our SMART goal, our challenge was to explore tinkercad and make our 3D printed build. We will hopefully reach our goal by day 4, and we did. We are creating this because we both thought it was interesting. We will be able to complete our goal because we have all the resources like tinkercad and the 3D printer and the knowledge from the launcher to successfully master this goal. We will be able to create this and learn to use tinkercad. We will use tinkercad to create a scaled mini basketball hoop by 3D printing it.
About our technology, we use tinkercad, which is a site for creating 3D models, circuits, and other things. It also has tutorials for moving, copying, tilting, and resizing the shapes, which are provided by a menu on the side of the shape creating platform.
What did we learn? We learned about 3D printing and tinkercad. We learned how 3D printers work and the patterns that they print in. We also learned, oh man, I cut off, okay. And Wyatt learned how to group things in tinkercad.
Problems that we had, the only problem I had was trying to catch up to Parker's work since I was gone a day and trying to help him out. I eventually caught up and helped him on designing the tinkercad and with putting together the basketball hoop.
Oh
Okay.
man,
Oh
my
man.
slides keep cutting out. But, this is our basketball hoop. You know, it's just small. And then, you know, there would be a picture of a real basketball hoop.
Yeah.
And we utilize the 3D printers a lot in this school. Mr. Ponzer has made a lot of cool things such as wall clips, a little skeleton with joints, and a battery/glue stick dispenser. That's the little skeleton guy. He also hangs on to here, which we definitely meant to do.
Vocab words. These are all the words we learned during this project and already known. Filament, a thread of material fed into a 3D sprinter apparently and extruded for fabrication. Flow rate, a rate at which filament flows through the extruder. Extruder, the printing component of a 3D printer through which filament is heated, passed, and laid. Print bed, the surface where the 3D manufacturing process takes place.
Our conclusion, drawing techniques through tinkercad with basic skills and lessons. Those were pretty easy. tinkercad pretty much shows you how to do all of it. We learned how to design our own 3D object and how to print our own object. 3D printing is the use of filament to create 3D objects. We would do this launcher again. We would change our project to something that can fit in the 3D printer a little bit better. This almost didn't fit. We had to scale it down to I think like 90% or something like that. Finishing the project a little bit better. We should make the holes bigger on the pegs because the 3D printer prints sharp corners, so they don't fit exactly in here. We had to sand them down and cut them down a little bit.
Here's an example on how you could use like the 3D printer every day. So your son just broke his favorite plastic toy and he got depressed. I could use a 3D printer to recreate the toy and make the son happy.